Hello, today we're going to be covering the TCM U3 and a comparison between its baby brother, the TCM U2. The U2 is a smaller display. As you can see, it's monochrome. We use the cursor control keys here to move up and move down on the display. I've got connected to it right now is the Leeb type tester. This is a rebound type. It fires a little thing called the impact body at the part to do the test. And if I go in now into measuring, I select that. This is where the test is done. It has similar sorts of, let's go back out of this. Settings is this display, but you've got to scroll through it. Obviously it's much smaller. So one of the key things is that with more keys, it's much faster to get to a specific display or function than it is on this much smaller, very compact device. You can see it's very narrow, extremely lightweight. There's two rechargeable batteries that are inside. You remove the cover to recharge. On top of the unit here you can see this is where the LEMO probe connector is, and here we have USB, and this is for communication to a PC, and we include the software for the PC side as well. This unit can take the UCI probe, either the 10 or the 50N, and as I've already shown, the Leeb type also. It doesn't have as many settings for the calibration as its bigger brother, the U3, so if I just show you that. Calibration. Here you can see this is the display, so we have HRC, Brunel, Vickers, and then a user-defined one here, so you might want to do Shaw perhaps. Here we have steel, stainless steel, alloy steel, and aluminum, and then a user-defined one. These are pre-configured for the D-type probe, and on the UCI type probe, we pre-configure for steel for HRC, Brunel, and Vickers only. You can of course calibrate it for your own materials, even things like titanium, or very exotic stainless steels and so on. So I'll just power this one off. And here on this device you can see that the display is showing a clock right now because it's gone into its timeout mode. The display dulls a little bit to save the batteries. So I hit any key and now the display comes alive. Clearly it's colour, and we can very quickly just move around these various parts of the display. So we have measuring, top left, then calibration. Archive is where we store the tests for upload to a PC later on, or just a review on the display. Settings is for changing the click on the keyboard when you press it. The timeout for the display to switch off, or the unit to switch off to save batteries. The brightness, all of those sort of things are available here under the user settings area. So just hit the back button. And information is about our company, so you can see the phone number and the website address and so on. You don't have to look it up, it's right there for you. And if I go up here to measuring, this is where we do our measuring our actual tests. So if I hit the button here, we go into that mode. You can see I have show up the top left hand side here is the display for the battery. It means it's on the memory as well. Right now I have HRC as my setting, and I'm going to be testing against steel, and I'm in graph mode. If I want to change the material, I just hit the material button and I can scroll through the different material types. And as I said before, we only configure, in fact any ultrasonic tester company does, any device for steel only. You can calibrate for your own materials, all you just need is some samples of the right hardness. So I'm going to reselect that, and then under the scale is for the Rockwell C, Brunel, Vickers, HRB, Rockwell B scale, Shaw. You've got your own user-defined fields, and we can even do the tensile strength material brace based on the Brunel hardness of the material. So we're working here in HRC, and what I'm going to do now is to show you just how super accurate these devices are. Here I have a NIST traceable test block. This has a tolerance on it of plus or minus 1 HRC, and the hardness is 23.17. and I have a 47.3, and its tolerance is plus or minus 1 HRC as well. And then lastly, we have a harder block, a 64.31, and it's plus or minus 0.5 HRC. So just starting with the first test block here, softest one, bring the probe over. Hopefully the cable is in the way, you can still see the display. There, with the puck here, if I press down on the sides, I can get a very nice reading. There's 22.8, 20.9. Now I moved it a little bit, so it's a little off. Really nice feature. Back off, I don't like that one. And you can see here, extremely repeatable, okay? You can see also that when I press down, it's showing me a display here of, that kind of shows graphically the little diamond tip touching the part. So when I move down on the part, touches, and then there is a test done. So there I have 3 tests. I'm now going to go to 47.3. And it's showing 47.5, and you can see here on the chart it's jumped up. And if I do another test here, okay, this was way off because I moved the device, so I'm just going to use the backspace over it and just do another test. Okay, so 47.3 was showing 47.5. Last one here is the hardest block that I have in this range, and again doing a test. 63.7, 64, 63.3. So you can see super accurate, bearing in mind that this has a 0.5 tolerance on its hardness across the surface. This had a 1 tolerance, and this had a 1 tolerance as well, and we are well within those tolerance bands based on these traceable test blocks. Another nice feature of this device is that we do include the puck. So if I screw this off, you can see here is the diamond tip on the end, and it's now much narrower, so we can get into tighter spaces on parts where it might be the gear, for example, and we wanted to angle it over to get into the face of the gear or into a groove. If we leave the puck on, it's easier for new users to use it with this because of this function of just pushing down on the sides. And we can also reverse the puck itself. I was actually using it on this face, but this is the one designed for flat faces, so we'd screw it on like here, without cross-threading it, of course. And so now for flat faces, for doing a test, or if I reverse it, now it's for cylindrical parts. So perhaps like this, I can put it onto the part and know that I am exactly perpendicular to when I'm doing a test. So nice little extra with this. Like I say, it comes with the unit, and at our price point, even if you bought both probes, the 50 and the 10N, and the wireless printer, and in fact we include the software free of charge and the cable, we're still so much less expensive than anybody else on the market. It's just quite incredible what we were able to do with this device. So let's look here a little further. On the graph, we can see here it's showing the steps across, and if I go into mode, I can change it to histogram, and this shows each of those tests in a bar type going out. Go back into mode again. I can see the statistics, but it doesn't really make a lot of sense, this one, because typically you're doing, tests on one hardness, and you want to do a whole bunch of tests and see what the average is, what the deviation is, and so on. So I did 9 tests, and it's saying my average is 44.5, but of course that's an average between my lowest test of 23 and my highest of 64.31. If I want to, at any point, I can then print to my wireless printer. I'll just power it on. Button's on, I just hit the middle mouse button, and immediately it does a printout. So I can see I have 23, 23, 23, 48, 46, 48, and 64 and 64. I can sign this. The date is shown when the test was done. That's a UCI probe, the serial number of the probe, the fact that I'm testing steel, and it's HRC, and there's all the stats. And of course this can be taken off and included with your test part. Another really nice feature of this unit, if I just go back up to mode here, is our smart function. I'm just going to get rid of all of these. And if I go now into smart mode, what smart does is it will read 3 tests, and if any of those tests are varying by the tolerance I can specify in the unit, it will automatically delete those. So if you do an erroneous test, it will automatically dump it. So I'll show you how this works. If I pick this 47 block here, for example, and I do a series of tests, you can see how the display is showing without the numbers being solid. And after 3 tests, if they are all within that tolerance, it will fill those in, as it has done. Okay, so I have 8.4. I do another test. Okay, now I'm going to jump to a material. Say this was a testing, and it was another part that I was testing, expected to be around 48, but I know it's 64. You can see here the little red dot has actually taken that test, but it's ignored it, it's tossed it out from my tolerance band. So it's a great way for new users, if they do a little bit of an erratic test, it'll automatically delete that rather than having to hit the backspace button. Great feature. Alright, so now we're going to look at the D-type probe. I'll just power the unit off and unplug this one. And now I'm going to get my D-type probe here, plug it in, lining up the little red dots on the LEMO connector, and I'll power on. It takes a few seconds just holding it so you can't actually accidentally bump it on. And I'm just going to now talk about the D-type probe. So this is what we call a Leeb type probe. And what it is we push down on the handle, and a little click happens, and what it's done is grabbed a thing called the impact body and pulled it up inside. So when we do a test against a part, we press the little button on top and it fires this impact body at the material. So if I just do a quick test here, I'm going to screw off what we call the support ring, and this allows you to take out the impact body, and this is the little guy here. Super high precision machined part. It has a little carbide ball on the end, and the way that this is working is that this is pulled up inside like I'd said before. You press the button, this fires this at the part, it bounces off, and the rate that this passes is measured by a coil inside, and its rebound rate is then calculated mathematically to give a super accurate reading. Very, very, very capable device. Now the reason that we have these, in addition to the UCI, is that ultrasonic technology is great for ferrous materials that are of tight granular structure like steel, stainless steel and so on, but not much good for very soft materials, or certainly not for very grainy materials like cast iron. So you'd use this device when you were testing those sorts of materials. The thing is that these are not good for super thin parts, so parts thin like this, and the test block, in fact, the calibration block, is this great big guy. This requires thicker parts because of the technology, firing that little slug against it. It can't have a thin part because it'll just absorb the impact. Anyway, I'm powered on now. And if you look here, under calibration, you can see this is all the calibrations pre-set up for this device. Just go back out again, and then I'm going to go into measuring. Whoopsie daisy. Measuring. And I'm going to go back up here. I'm actually still in the last mode. And I'm just going to go in here and pick this. And I'm going to get rid of those tests. Okay, so now we're ready for a test with this guy on my part. And I'll just turn it over, and I can see that this is 57.6 HRC. And there we go. It's showing 58.3. So we're less than 1 HRC off, and the tolerance on this block is plus or minus 1. So we're actually well within tolerance. Super accurate devices, very, very fast, easy to use, and now an incredible price. Thanks.